Hello everyone, I am Ashutosh Kumar, BTech EPH third year, and this is my video presentation for PHN 314 microprocessors and peripheral devices. And my topic is on programmable thermostat control using 8085 microprocessor. So let's start with it. So what is thermostat basically that we use in our homes? There are multiple types of thermostat used in industrial commercial application, but here we will discuss the thermostat that is being used in our homes to control temperature and to maintain desired temperature with respect to the outside and indoor temperature. So thermostat is a temperature sensing device that measures the temperature and switch on and off the working of HVAC system to work at an efficient temperature. So basically it using a thermocouple, it sends the indoor temperature and outdoor temperature, and based on that the control circuit switches on and off the heater or the cooling system as per the requirement. Now as we move the thermostat temperature marker, like on the outside of the like in the figure itself there is plus and minus, so as you increase the temperature, so it rotates the thermometer coil inside it and the mercury switch, and then the current starts flowing through the mercury switches and it starts a relay. There is a relay circuit and it starts a relay that starts the heater that is being installed inside it, and based on it whether it needs to be cooled or it's need to be heated, it works like that. So this is the schematic of thermostat. As you can see, there are many switches and wires and connection. There is a relay that we are talking about, the heat relay, the fan relay, and this is the outdoor and indoor temperature sensor that is being controlled by 8085. So there have been so many pins like RH, R, W, Y, G, and C. Let me explain to you. The RH wire comes from the HVAC system, that is 24 volt AC transformer on the heating system, and the RC wire comes from the 24 volt AC transformer on the air conditioning system. The W wire comes from the relay that turns on the heating system. Here is the heat relay, and the Y wire comes from the relay that turns on the cooling system. So there are different wires for the heating and cooling, and it switches on and off with respect to our whatever temperature we need. And the G wire comes from the relay that turns on the fan. So our main focus is on the outdoor indoor temperature sensor that we have, that this is here connected to switch 1 and switch 2, where we will be using our 8085 microprocessor. So as discussed earlier too, using the thermocouple, it determines the temperature of outdoor and indoor. It works based on that. Let's proceed like how it works. So temperature control using 8085. Now let's say the outdoor temperature is capital T and indoor temperature is small t. Now if indoor temperature is less than outdoor temperature, then the 8085 microprocessor sends control signal to the relay circuit. It's thermosized relay circuit, and it turns on the heating process. And let's say if indoor temperature is greater than outdoor temperature, 8085 sends control signal to the relay circuit and turns off the heating process and start the cooling process. This way the room temperature is maintained at a desired temperature. Also the 8085 reads the equivalent temperature data from the display system that is shown here in the figure, and the data from the thermocouple is being sent to the display via normal analog to digital converter, that it converts the current signals to a volt to display basically. Now let's read the ALP for the temperature control using 8085. So initializing with the stack pointer LXI, the SNP register, and then initializing the 82255 microprocessor also, that is being connected after the 8085. So the whole interfacing system will be like, there will be 8085 microprocessor connected with the 8255, and then there will be analog to digital converter, and then there will be a display system. So here we are initializing the 82552, and the output will be given at 83H. Now one thing to note, that this 03H and 83H, this has been the data ports and control ports that has been already been selected. So let's start with the start loop. Like MVI A03H, it selects an input channel that will be the accumulator and gets high to low. This is SOC selection of channel and the ALE signals. This output will be at 82H, output at port X. This port X can be any, like there are 2 or 3 ports in the thermostat, so we can allot let's say port A, B, or any maybe C to the 82H. and this the input channel for the input data for all these will be outputted at the port X. Similarly, this is the checks EOC, like what channel has been active in the thermostat, and based on that there is a loop that has been started, if condition loop, like if EOC is equal to 1, uh, it will check if EOC is equal to 1. If no, then jump to L1. Now L1 is the loop again. It will again check EOC, and if EOC gets 1 finally, then it read the temperature T, that is the indoor temperature. Now this indoor temperature data can be saved into the B register by MOV BA, and let's say if input and output data are equal, this data variable hasn't been initialized, it's the output data. And if this is true, like the input data is equal to output temperature, then we can simply jump to the start loop again. And again, let's say if the indoor temperature is greater than the outdoor temperature, then we can simply jump to off. Jump off, what does the jump to off does? Off does, it sends the control signal to turn off the heater basically. And let's say if the indoor temperature is not equal to not greater than the outdoor temperature, then it sends signal to turn on the heater. Like similarly, it's done in MVIA01H. So 01H is the code for turning on the heater, and 00H is for the turn off the heater. Like in the off loop, we can see MVIA00H, and at the end of the loop, we can simply jump to display. Now display loop is the display, it move AB, it display the current temperature, like the current indoor temperature, what you can also change according to that. And then again you can call display to display current temperature loop by loop. And then again JMP start, we can repeat the process for further processing. So this is the application of 8085 microprocessor in controlling our room temperature using a thermostat. Thank you.